Block 1. The paradoxical question. What do your plane ticket, your favorite shirt, and tomorrow's lunch have in common? It's not just utility, it's molecular origin. You exhale CO_2 every second, a gas we treat as a climate villain. But consider the perspective shift. What if this pollutant is actually the most abundant raw material for human progress? We are standing on the edge of a fundamental transformation. We are moving from a world where we extract finite resources from deep, dangerous wells to a world where we harvest the atmosphere itself. This is not about cutting back on living. It is about changing how we build. By turning a gas into a solid, we are effectively deleting the problem and turning it into a foundation. Imagine a world where every city is a carbon sink, where your daily activities actually help to rebalance the atmosphere. We are talking about the biggest shift in material science since the dawn of the Industrial Revolution, where the air literally becomes the new oil, turning today's greatest threat into the bedrock of a new, sustainable industrial civilization, confronting reality and the carbon debt. For over 200 years, we have operated on a carbon debt model. We've been digging up ancient carbon, sequestrated in coal and oil deposits over geological timescales, and injecting it into our delicate atmosphere in a heartbeat. It's like draining a battery that took millions of years to charge. We've treated the sky as a free, infinite sewer, ignoring the fact that matter cannot disappear. It only changes form. This, however, was a result of limited technology, not limited ambition. Today, we are witnessing the birth of atmospheric mining. We are moving from the age of extraction to the age of circularity. It's a profound shift. We are no longer just passive victims of climate change, but active architects of our planet's chemistry. This transition is not about giving up comfort or luxury. It's about decoupling prosperity from ecological destruction. We are finally learning to manage the planetary carbon cycle, like an engineer manages a factory flow, ensuring that every molecule of CO2 is not a toxic waste product, but a valuable building block in our global supply chain. Scientific fact: every living thing on Earth is carbon-based. Carbon is the ultimate Lego of the universe because of its unique ability to form stable, complex chains with other atoms. Proteins, DNA, sugars, and synthetic polymers all rely on the same fundamental carbon skeleton. By transitioning to a circular economy, we stop viewing the planet as an exhausted mine and start treating it as a dynamic, regenerative system. This is essentially the difference between being a hunter-gatherer, scouring the earth for oil, and being a farmer, cultivating the atmosphere for the carbon we need. This isn't theoretical. It's the most efficient way to manage our resources. If we can master the capture of carbon, we make our industrial system immune to the geopolitical volatility of fossil fuel markets. It is the ultimate form of resource sovereignty. We are not creating new matter. We are reconfiguring existing matter to serve human needs, effectively ending our dependency on underground extraction and closing the loop of the planetary carbon cycle once and for all. Block 2. Technology and process. Capturing CO2 is a massive engineering feat. We distinguish between point source capture and direct air capture. Point source is the low-hanging fruit. We install capture units on the exhaust stacks of massive steel mills, cement plants, and chemical refineries. Since the concentration of CO2 here is extremely high, the cost of capture is relatively low. It is essentially high-efficiency recycling at the source of the waste. Then there is the holy grail, direct air capture, DAC. Here, we aren't limited to a factory chimney. We place massive, modular fan arrays in areas with high wind energy potential. These units act as giant synthetic lungs, pulling ambient air through proprietary liquid solvents or solid sorbents that selectively bind with CO2 molecules while letting the oxygen and nitrogen pass through. As we scale these facilities, the energy cost per ton of captured carbon is dropping exponentially, making DAC the foundation of a carbon-negative industrial infrastructure that can work anywhere on Earth, regardless of proximity to heavy industry. Engineering alchemy, the Sabatier process and catalysis. Once we have captured the gas, the real fun begins. We utilize the Sabatier process, a chemical reaction that combines hydrogen and carbon dioxide to produce methane and water. But modern engineering has pushed this much further. Using nanostructured catalysts, materials engineered at the scale of atoms, we can now steer these reactions to create long-chain hydrocarbons, which serve as the perfect base for jet fuel, diesel, and plastics. We are literally using electrons to stitch hydrogen from water and carbon from air together to form precise, useful molecules. It's akin to high-speed 3D printing at the molecular level. This removes the need for traditional oil refining. The electricity acts as the glue that forces these atoms into the configuration we desire. And the best part is that this process is becoming increasingly modular. Small-scale reactors can now fit inside shipping containers, meaning we can produce fuel on-site, right where the energy is generated, minimizing the environmental cost of transport and refining. The hydrogen multiplier. The entire circular carbon economy hinges on one critical component: green hydrogen. When we use excess energy from solar or wind farms to perform electrolysis, we split water into oxygen and hydrogen. This hydrogen is the essential reactant for turning CO2 into fuel. This makes green hydrogen the most important energy carrier of the 21st century. It allows us to solve the problem of intermittency, the fact that the sun doesn't always shine and the wind doesn't always blow. Instead of letting that surplus energy go to waste, we bottle it in chemical bonds. This turns our entire electrical grid into a massive energy storage battery, creating stable, storable liquid energy that can be shipped, pumped, and used in existing infrastructure. It transforms renewable energy from a volatile, unstable input into a reliable, high-density fuel source, essentially bridging the gap between the clean energy revolution and the reality of our current transportation needs, all while removing carbon from the environment in the process. The biotech frontier, food from air. Beyond materials and fuels, we are entering the era of atmosphere-grown nutrition. Through microbial protein synthesis, we are feeding captured carbon and hydrogen to hyper-efficient, lab-cultivated bacteria. These microbes are essentially tiny, self-replicating chemical factories. They take in the CO2 and H2 we provide and convert them directly into high-quality protein-rich biomass. This can be processed into flours, oils, and even ingredients that mimic the texture of meat. This is the ultimate revolution in food security because it decouples protein production from land use, water consumption, and the climate-sensitive nature of traditional agriculture. We could theoretically grow the entire world's protein requirements in vertical urban bioreactors, saving billions of hectares of forest and agricultural land that are currently used for grazing and feed crops. It turns food production into a sterile, controllable industrial process free from the risks of drought, pests, or supply chain disruptions, ensuring that humanity can scale its food supply infinitely without destroying any more of the biosphere's natural habitats. Block 3. The payoff and conclusion. Your future shirt won't just be sustainable. It will be a piece of atmospheric engineering. The fashion industry, currently one of the most resource-intensive and polluting sectors on the planet, is being completely overhauled. By synthesizing polymer resins from captured CO2, we can now produce high-performance polyester, nylon, and carbon fiber materials that are identical to their petroleum-derived counterparts, but with a carbon-negative footprint. This means every pair of sneakers, every jacket, and every piece of outdoor gear you own becomes a literal storehouse of carbon that was pulled out of the air. This shift is not just about reducing waste, it's about creating a closet as a carbon sink. As we master this technology, we will see the emergence of materials that are stronger, lighter, and more durable than anything we've pulled from the ground. We are moving toward a future where our clothing lines are essentially part of the climate tech sector, proving that we can maintain our high fashion standards and material comforts while simultaneously cleaning the atmosphere through our very choices in the retail sector. Economic paradigms, the new geopolitics. This is the most significant economic pivot of the century. Traditionally, geopolitics have been defined by who owns the underground deposits of oil and gas. Those nations controlled the global energy flow, but the circular carbon economy flips this. Now, power belongs to those who control the technological stack, the capture infrastructure, and the renewable energy generation. Countries without oil reserves are suddenly the most promising players in the game, as they can leverage their wind and solar potential to become major exporters of synthetic fuels and carbon-based materials. This leads to a profound decentralization of global energy power. We are moving toward a world where regional energy autonomy is the norm, rather than the exception. Business models are shifting from extraction-based profits to process efficiency profits. The winners of this new era will be the innovators who lower the cost of capture and the engineers who refine the catalytic pathways. This transition is not just inevitable. It is a massive economic stimulus that creates a new class of high-tech manufacturing jobs and incentivizes global cooperation on infrastructure development. Philosophical shift and the answer. Ultimately, we are witnessing a shift in the human psyche, from a species that consumes its environment to one that manages its chemistry. For millennia, we were at the mercy of nature's cycles. Now, we are learning to define those cycles. This isn't just fixing a climate problem. It's the graduation of our civilization into a new tier of technological maturity. We are learning to write in real time with the very atoms that construct our sky. The science is robust, the technological scaling has begun, and the era of air-based production is here. So, to answer our initial question, your flight, your shirt, and your food are all converging into one single, coherent reality. We are mastering the ability to recycle the very building blocks of existence. We are the ultimate recyclers, and we are just getting started. Subscribe to join the conversation, because here we analyze how the seemingly impossible becomes the inevitable, proving that humanity's greatest stories are yet to be written by our own ingenuity and our mastery of the natural world.